Okay, so we're back. I had to take a brief filming break to chase children away. Okay, so we looked at side angle side. That is the included angle, right? The angle is in between the two sides. You see how it's included. Now let's look at angle side angle. So we've got angle side angle, and that doesn't have an included angle, it's got an included side, which means the side has to touch both of the angles. Excuse me, I apologize for these allergies. So if I've got two triangles here, again, I apologize, they don't look exactly alike. And I've got, let's say this is 120 degrees, and this is 30 degrees, and this is 15. And 120 degrees, and this is 15, and this is 30. I can mark these two sides congruent because they're both 15, right? Because you're used to seeing the side markings. If I went up here and marked these, I could mark this. I could mark this as well. So this would give us angle side angle, because what we have is a side that is connected to two angles, and they're in the same sequence. The side has to be exactly between the same two angles in the same spot. If 15 was over here instead of over here, that wouldn't work. This is 15, it's between these two. This 15 has to be between these two, so that's how you would mark angle side angle. So you've got, let's see, we've got M and O. Again, I'm very original how I name these, in ABC. So we know that angle N, which could also be angle MNO or ONM, is congruent to angle B. We have angle O, which is congruent to angle C. And we've got side NO, whoops, wrong symbol, no, which is what I've been saying to my children a lot today. NO is congruent to BC. So with those, I can actually say angle side angle because they have a side between two angles that's identical, and that's how you do angle side angle. So let's look at two more that we have. We have angle angle side, and angle side is different than angle side angle because now the side is not in between. There is no included side. There's no included side. So if I have my two triangles here, and let's make this triangle cow because I just wanted to do something with a word in it. And we'll make this triangle bat. I know, I'm getting more creative. And let's say that this is 50 degrees, and this is 75 degrees, and this is 50 degrees, and this is 75 degrees, and this is 12, and this is 12. These two triangles will be congruent by angles angle side, because what we have here is we've got, excuse me, what we have here is we have 12, angle, and angle. We have side, angle, angle. Notice how this side is not included. The included side would be in the middle. I'm going to mark that 12. I'm going to mark that 12. This angle is 50. Put one arc. This angle is 50. This angle is 75, and this one is 75. So I've got angle, and a side. 50 and 75, and then a 12. 50, 75, 12. So that's angle C is congruent to angle A. Angle O is congruent to angle T, and side OW is congruent to side TB. So I've got an angle, and a side, so you would write it AAS. Okay, so that's angle, side. Again, the difference is you see where the side is here, and on angle, side, angle, you see the side is in between. The side's in between. This one, the side is not in between. Okay, so our last one is hypotenuse leg. And hypotenuse leg can only be used with right triangles. Because what kind of triangles have a hypotenuse and a leg? Right triangles. So we can use hypotenuse leg to mark two triangles are congruent. So as long as I know the hypotenuse and one of the legs match, That's enough to say they're congruent by hypotenuse leg. So the hypotenuse, the leg, so I've got two right triangles, HL. And again, let's do JKL and PQR. So I know that angle J is congruent to angle P, and they are right angles. You have to indicate that. You don't have to indicate it, but I always do. And then you've got JL is congruent to PR, and you have KL is congruent to QR. Okay? So this is enough for us to say HL, which is hypotenuse leg. Okay? So now you've seen the 5. Okay, now you've seen the 5. So what we're going to do is we're going to look at some examples of when we can, of naming triangles congruent. So here are your 5 again. You have side, side, side. You have side, angle, side. You have angle, side, angle. You have angle, angle, side. And you have HL. Now, there are 2 that you cannot use. First thing you cannot use is AAA. We just got done talking about similarity. Just because the 3 angles are the same does not mean the 3 triangles are the same. For example, and let me move this over a little bit so you can actually see it. Here are 2 equilateral triangles. What do we know the angles are always in equilateral triangles? They're 60, right? These 2 triangles have the same exact angles, but they're different sizes. So AAA does not work for congruence. It works for similarity, but not congruence. So you cannot use AAA. The other one you can't use is everybody's family favorite, ASS, angle side side, because here's an example of where angle side side doesn't work. Let's say I have a 30-degree angle here, and this is 14, and this is 8. I can draw another triangle that has angle, a side, and a side in that sequence that does not look like this one. And it looks like this. I'm going to keep that side that's 14. I'm going to keep that 30-degree angle, but I'm going to take this and I'm going to swing it over, so that'll still be 8. And look at, I have a 30, a 14, and an 8, a 30, a 14, and an 8, and those triangles are different. So this one and AAA do not work for congruence. And that is the same as SSA if you want to spell it backwards. Now, I will say ASS looks like HL in a right triangle. That's why we call it HL. That's the only time that that sequence will work, and you'll never call it that. You'll call it HL. All right, so let's look at our 5 congruences here. And let me try my hand at some more artwork. All righty. Example 1. All right. Let's say these 2 are congruent and these 2 are congruent. How do I know these 2 triangles are congruent? Well, I'm going to look at these 2 triangles and I'm going to determine, all right, what am I given? Well, I'm giving two pairs of sides. And then what can I infer? Meaning, what can I determine from the picture that's not already given? Well, what kind of angles are these? These are happy little vertical angles, just like happy trees. You got vertical angles in there that you can mark congruent. So now I have an included angle between 2 sides. So that would be side, angle, side. Okay? Alrighty. So let's move on to another one. Let's do this one here. Okay, and let's say, for example, we'll start naming these 2. I'll give you some. We'll go P, Q, R, S. And we'll say this. R is the midpoint. And we'll say that QR is perpendicular to PS. So nothing is marked on here. But what can I mark based on what I'm told? Well, first of all, R is the midpoint. What does that mean? That means that PR and RS have to be the same. R's in the middle. So that gives you a side. It tells you that QR is perpendicular to PS. What does that make these angles? Right angles. And then they share this side. So you can use the reflexive property to establish this side. So once again, these two triangles are congruent by side, angle, side. I've got two sides and included angle. But you had to use the information you're given. Okay? Alrighty, let's move on to another example. And we'll do that example over here. And I'm actually going to name these here. If we come back and look at this and I were to ask you to tell me the congruent statement, you would tell me triangle PQR is congruent to triangle SQR. If you were doing it up here, if I made this A, B, C, D, E, you have to make sure that you match things up. Triangle ABC, if I say ABC, I can name the first triangle anything I want, but what I name the second one depends on what I name the first one. ABC goes this way. You go from no marks to one mark. So that means EDC would be the triangle it's congruent to. And then you match them up. BC goes with DC, that's correct. AC goes with EC, that's correct, they're in the right order. Okay, so I'm going to throw this in here. Alright, so we're going to throw that in there. And so we're going to use that to our advantage. What are these? That means parallel. So BC is parallel to AD. I don't know if y'all can see that. We'll come over a little bit. There we go. And BA is parallel to CD. Now, we haven't talked about parallelograms and special quads and all that stuff, so you can't say that those sides are congruent yet. What do we know they share? Reflexive property. So by reflexive, I can say that they share that side, right? So there's one set of sides. Parallel lines create our special favorite, which is alternate interior angles. So I'm going to look for the two pairs of alternate interior angles. And those would be BCA, because of this one, these lines, BCA and CAD are congruent because those are alternate interiors. And then if I look at these parallel lines here, BAC is congruent to DCB because those are also alternate interiors. Now look at your two triangles. I've got an included side, angle, and in the same order, angle, side, angle. So this is angle, side, angle. Use those parallel lines to your advantage. So what I've shown you in these three examples are ways that you can apply midpoint, you can apply perpendicular to get your right angles, and you can use different types of inferred information, vertical angles, reflexive property to create congruent triangles. Now let's look at a couple more examples of this. And so we're going to move right along here. And let's use pink, because everybody loves pink. Okay, so we're going to use pink now. Alright, so I'm going to give you another example of something that we can use. And I'm helping you out for proofs. These are things you can use for proofs. Okay. I'm going to say the following information. I'm going to say RS, or actually, you know what? I'm going to give you that RK is congruent to RT. Okay, RK is congruent to RT. I'm going to give that to you. That's a given. Okay. Then I'm going to tell you that RS bisects angle KRT. And now I'm going to tell you that's all the information I'm going to give you. So let's look at what we have. I already know these guys. I've been told that they were congruent. What does this bisect thing mean? Well, it means cut in half. It means to cut in half. So in order to cut in half, that means if RS bisects KRT, that means that KRS is congruent to SRT. Because it says RS bisects that angle, right? Okay. So RS bisects that angle. Now, I still need one more piece of information. Well, here's that old reflexive property again. What do they share? They share RS. So now I can say they are congruent by side, angle, side, because I have an included angle. Side, angle, side, side, angle, side. Okay? Side, angle, side. So that's how you can use bisector. So we've used bisect, we've used perpendicular, we've used midpoint, we've used reflexive, we've used alternate interior angles, we've used vertical angles, and we've used, and that's pretty much it. Those are the things that you're going to be using when you're proving triangles congruent.